Hey everyone, welcome to section 1.2, which is our first introduction into limits, which is graphically and numerically. So before we really get started, what I want to do is show you this quick video on Matchbox cars and limits. So enjoy! We're going to get some idea of a conceptual idea of limits here using Matchbox cars, Ferrari, and this other Matchbox car. It's number 27. And that's about all I know. I think it says Tech 227ium. I don't know. Anyway, let's say these two cars are going to be driving along this road. We're going to call this road a function. Okay? So this red car only travels on its road. This yellow car only travels on its road. Alright? So normally what has happened is that when we're looking at this, we say, this red car, you just keep on going along, he touches his road at all points, and he can turn around, and he can drive real fast, he can drive real slow, they can both drive together, we can find like 2 points, they can tail each other, whatever we want to do. Right? Oh, easy there, Ferrari. But now we're going to look at this and say, there's something weird going on here. So this car is going to go from this side, see, and this car is going to go from this side, and they can only stay on the road, and if there is no road, they stop. So these two cars are going to fly together, and then they stop. And you say, well, why? Shouldn't they have ran into each other and made a bunch of noise and then, fallen over and stuff like that? Well, here's why they didn't do that, and that's because, if you see, it says the bridge is out. So there was a bridge there. We made a bridge, but someone forgot to actually construct it, so the bridge is out. So these two cars, being very astute drivers, said this. I'm going to go along. Oh, I see the bridge is out, and I better stop. So that's the idea of a limit, is that there might be a hole or there might be something wrong with our function where we don't actually get a value right here, kind of like when you divide by 0. So this car, if these two cars go together, if they look like they're going to crash, they probably will. That means the limit exists at that point. Now, let's say we have a road like this, and let's say there was some big shifts going on. Right, so this car is going this way, approaches this spot. This car is going this way, approaches this spot. If they don't approach each other, like they're not going to crash, there's going to be no limit. The limit won't exist. Alright? So this would be one where it's like, oh, this one goes here, this one goes here, no limit. If we have it right here and we say, uh-oh, let's go back to the bridge being out, bridge is out, and this guy is driving this way, this guy is driving this way, and look like they're going to crash, but they don't actually quite touch. The limit exists where they're going to touch. Alright? Great. There it is. And now, play with the Matchbox cars. Oh no. Okay, and we're back. Wasn't that fun? Yes. Now let's actually get into some functions like the road. So we're looking at f of x equals x cubed minus 1 divided by x minus 1, where x can't equal 1 because if x equals 1, we get divide by 0 and the whole thing falls apart. So you always ask, what happens at this point? And sometimes you say, divide by 0 error. Well, now we can actually start to look at what can we do with numbers that get really close to 1? So what happens at x equals 1? So what we're going to do is let's just quickly go over here to the graphing calculator. We plugged it in here. And now let's graph it. And this is the equation. And you say, well, okay, this is -1, 0, 1. And we say, well, there's nothing wrong right here. I don't see a problem. Okay, well, let's just actually move me a little bit. Whoa, hey. And then let's go to the table. And if you look at the table, you see there's an error here right at 1. Everywhere else, there's no error, but right at this point, then we're going to have a problem. And we knew that was going to happen because we know it's going to be divided by 1, or divide by 0 error. So what we're going to do is if we just go back here, let's just look at what happens at x equals 1. Well, I've got a table of values here. Let's just kind of zoom in on this table of values. And if you see, I've given some numbers, so x is 0.75. Y is here, and then it goes to 0.9 and 0.99 and 0.999. I got really close to 1. I get 2.997, really close to 3. And as I go from the right, 1.25, and then 1.1, and then 1.01, 1.001, and I'm getting close to 4, closer to 3, really close to 3, really, really close to 3, and this was closer to 2, closer to 3, really, really close. So what we're doing is from both sides, we're going in and we're getting really, really close. So x approaches 1 from the left, and x approaches 1 from the right. What number are they both approaching? Well, we're approaching 3 from the left side, and we're approaching 3 from the right side. So we'd say that if this 1 were to be there, it would approach 3. Alright, so our limit would be 3. So here's an informal definition and informal notation of a limit. Let's just make sure you can read the whole thing. All right, there we go. If f of x becomes arbitrarily close to a single number, when we say arbitrarily, mean just really, really close. I mean, we can always get closer. I just pick these numbers. We can pick any numbers we want to get really, really close. That's kind of the idea of arbitrarily close. We just pick some numbers and say, as it gets close. If it gets close to a single number L, as x approaches C from either side, they have to approach the same number, like the cars had to approach each other, right? That had to be, then we'll get a limit, right? So they have to approach the same number from both sides. And we can say that the limit of f of x as, there we go, as x approaches C is L. And here is your notation, the first notation. It says LIM, underneath it, x arrow C, and then f of x equals L. And you say it as the limit as x approaches C of f of x is L. So the limit as x approaches C of f of x is L. Alright, and here's something you should know. Limits will be on the AP exam. Alright, and let me just pause it here for a second so I get you your assignment ready. Alright, sorry about that. I'm back, and now here's your assignment tonight. The discussion above gives an example of how you can approximate a limit numerically by constructing a table and graphically by drawing a graph. Try approximating the limit. So this again says the limit as x approaches 2 of x squared minus 3x plus 2 all over x minus 2 numerically by completing the table. So all you have to do is complete this table, and then you're going to use your graphing calculator to see the same thing, to see if you can find that spot where it happens. Alright, also, here's your trivia question you can answer right along with this one. What Hoops Sensation asked to select a flavor for the new Powerade Flava 23 picked sourberry? Hey everyone, as we leave today, I'm going to leave you with a little clip from Mean Girls, the movie, the 2004 or 5, I don't remember, 2000. This movie right here, a clip, 2004 smash hit, all about math. Totally awesome. Check it out.
Contestants, find the limit of this equation.
Calling somebody else fat won't make you any skinnier. Calling someone stupid doesn't make you any smarter. And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you.
The limit is -1.
Oh, crap. I lost.
That answer is incorrect. Now, we are in a sudden death. If Miss Heron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh, God, he looks so cute. Okay, focus, Katie. What was on the board behind Aaron's head? If the limit never approaches anything, the limit does not exist. The limit does not exist!
Our new state champions, the North Shore Mathletes.
How do you like me now? You like that? Yeah! Get some! Get some!
Good luck.